Okay, this is about attempt 100 for me, but you guys don't know that. So hopefully this one goes more smoothly. I'm still getting used to this. Okay, so what we're going to do is we're going to examine a question that was on the probability handout, the counting and probability handout that I gave you a couple of class periods ago. And we're going to be looking at specifically right here, this is question number 7, and it's from section 2, which was entitled Permutations and Combinations, and it's under the problem section, which is Roman numeral 5. So I'm not sure the exact letter it corresponds to. I'll let you look that up. All right, here's the situation. We've got that the U.S. Senate has 100 members, 45 of which are Republicans, 52 of which are Democrats, and 3 are independents. How many committees consisting of a Democratic president, vice president, and treasurer, 2 Republicans at large, and 1 independent at large can be formed? So the way we're going to tackle this problem is we see that we have 3 choices made in sequence, and the order in which you consider those choices doesn't matter. We'll go ahead and consider it as, first of all, for the first choice, we're going to be selecting the 3 Democrats. Okay, and for the second choice, we've got selecting the 2 Republicans, and finally we have the choice of selecting the 1 independent. Okay. What we're doing here then is we're making a sequence of choices so we can apply the multiplication principle, sometimes called the fundamental counting principle. And so when we do that, we can simply multiply the number of ways each of the choices can occur to give me the total number of outcomes for the sequence. So we're going to take the number of ways you can select 3 Democrats, and we're going to multiply that to the number of ways you can select the 2 Republicans, and to that we'll multiply it the number of ways that you can select the 1 independent. Okay. Looking at the first question, how many ways can you select 3 Democrats? Notice we've got a counting question inside of a counting question. And looking at the original situation, we've got a president, vice president, treasurer, which means that the selections are ordered, or you could think labeled. That is, if we pick 3 individuals, labeled the first one president, the second one vice president, the third one treasurer, that is not the same arrangement than if we labeled the third one president, the second one vice president, and the first one treasurer. So the order matters here. When order matters in looking at the grouping, then we have a permutation. So we're going to be looking at a permutation and counting up the number of ways we can select the 3 Democrats. So when we handle permutation questions, we say, well, how many objects do I have? And that's 52. And how many am I picking? In this case, I'm picking 3 of them, 1 for each of those 3 positions. Okay. We're going to multiply this to the number of ways I can select the 2 Republicans. In this case, looking at the setup, we're picking 2 Republicans at large, which means that you can't tell the difference between a pairing. That is, if we choose candidate 1 and candidate 2 to be our 2 Republicans, you can't tell the difference between that committee and the committee that has candidate 2 and candidate 1. They are the same committee. That is, the order doesn't matter, which implies that this is going to be a combination. Okay. So it's going to be a combination, and in this case we have a total of 45 Republicans to choose from, and we're going to be choosing 2 of them. For the final portion, we're going to be looking at selecting the 1 independent. Now, you could look at this in a little bit more complicated light to say that, well, you're choosing an independent member from the committee, and you can't tell the difference in the order. You're only choosing 1, so you could argue that it's a combination on 3 objects, choosing 1 of them. Of course, this just simplifies down to 3, and you can answer this question much more simply, right? I've got 3 objects. Select 1 of them. How many ways can this be done? You don't need this more complicated machinery of a combination. So we'll just go ahead and put a 3 here. All right. Well, I've cheated. I've actually already calculated these, I think. So let's see what we've got here. In selecting the number of ways that I can, or the number of permutations on the Democrats, this number comes out to 132,600. Okay. And we're going to multiply that to, if I take the number of combinations, 45 objects, choosing 2 of them, that comes out to be 990, and then times 3. Crunching that number then gives me 3 ooh boy, that's a mess. 393822 followed by 3 zeros. Wow, what a mess. Like I said, I'm still getting used to this. So we've got 393,822,000 different committees, different ways that we can form the committee.